So after discussing about the different type of graphs, let's talk about some more graphs. Graph for xi square and the distance from the nucleus. Now we know that as we go far away from the nucleus, we discussed earlier also, if we go far away from the nucleus, xi decreases. We have discussed this thing in the graphs of xi versus r. So the probability of the finding out of the electron decreases. The maximum probability finding out of the electron is near the nucleus. In the nucleus it is 0, near the nucleus it is maximum, then it is keep on decreasing as we go far away from the nucleus, and it becomes 0 at the end, and then next shell starts. So therefore we had same type of graph for xi versus r for 1s, but here what we have to do, if the values there was 5, 4, 3, 2, 1 like this, here the graph, the values will be 25, 16, 19, 4, 1 like this. It is only just the square of wave function, nothing else. So same type of a graph we will get in this case also. So what we are doing? We are going away from the nucleus and the probability is decreasing, and the probability is determined by xi square. So xi square is decreasing like this. So this was 1s. Let's talk about 2s. Now if I go away from the nucleus in 2s, we have this region. In this region you can see that there is no electron over there. First the probability will decrease and then it will become 0. After that it will again increase, then decrease, then again it will become 0. That we have already studied in the case of xi versus r. So the probability near the nucleus is maximum. It is maximum. It will keep on decreasing, keep on decreasing, keep on decreasing, and it will become 0. Probability becomes 0 at this region, and this region where the probability of the finding out of the electron is 0, the region is called node. So this is node, and when we go again further, the probability will first increases, then it will decrease, and then 3s will come. Now let us compare this graph with xi versus r. Now in xi versus r we have already studied that the graph will come like this, and it will go in the negative value and then it will increase afterwards, right? That we have already did in xi versus r previously. Now the square of positive is positive and the square of negative is also positive. That's why this graph, if we take xi square, not xi, if we take xi square, this graph will become like this. So this is the node. Near the nucleus, the probability is maximum. It will keep on decreasing, keep on decreasing, keep on decreasing. It will become 0 at node, and then it will increase in the second shell, and then it will decrease, and before the third shell it will become again 0. So this is the graph, and you can see from here, if we go like this in this direction, here in the nucleus the probability of the finding out of the electron is 0. Near the nucleus it is maximum, and here between K shell and L shell it is 0, and that point, this point is called node. So this is node. So this node is here, and then again it will increase, then decrease, and then third shell will come, so it will become 0. So this is the graph between xi square and r for 2s. Now for 2p. The same type of graph will come because the nature, or you can say the shape of 2p, it is like this. The probability is increasing as the size of the lobe is increasing, and when the size of lobe will decrease, the probability will decrease, and you can see clearly from here that first it is increasing, then it is decreasing when we are moving in this direction. So definitely graph will become like this. Now let's discuss the graphs of probability distribution function. Now first we have to know that what is probability distribution function. Now the radial probability distribution function gives us the total probability of finding out the electron r distance away from the nucleus. Means this is 1s. Is electron moving in circular path? No. Where is the maximum probability density? Near the nucleus. If we go far away from the nucleus, what will happen? Probability density will decrease. But the shell, the size of shell will increase, the number of points, the number of positions will increase. Now what we want? We want a spherical surface whose surface area should be significant and the probability should be also more. What is happening here? If I take this area, here the surface area is more, but xi square is very less, and near the nucleus xi square is high, but surface area is very less. So this term 4 pi square means the surface area of the shell into xi square should be maximum, and this is called radial probability distribution function. So what I want this sort of surface. Here the xi square and pi r square both will be significantly large, and we know that by mathematics that if there are two variables, if both are small, the value will keep on decreasing on multiplying them, and if both are increasing, the value will keep on increasing. But if one is increasing, one is decreasing, we will get a graph like this. So for 1s, if we go far away from the nucleus, shell will increase, xi square will decrease. Therefore, we are getting this type of a graph. Let me tell you one more thing. If we see the peak of this graph, this point, this peak, and if I drop a perpendicular on the x-axis and find the distance, that where is the maximum probability distribution function, that distance for hydrogen atom is 0.529 angstrom. It means that Bohr was correct. So this is a graph for radial probability distribution function versus R for 1s. Let us see the graph for 2s. Graph is like this. So definitely if the surface area is increasing, xi square will decrease, xi square is increasing, surface area will decrease, we will get this dome type of graphs, and this is the node, the same node we were getting there in the case of xi versus r and xi square versus r. This is between K shell and L shell, and it is somewhere here. If we move from here to here, so we can say that from 1s to 2s there will be a gap between, and 2s before 3s there will be another node. So for P, again for its shape, the graph will be like this. it will increase, then again increase, then it is decrease, then it will again decrease, and on moving we will get same type of graph, right? So these were the graphs between xi square versus r and the probability distribution function. Let's discuss about nodes.